Hello guys. So we'll just wait for a couple of minutes, then we will start the session. Good evening, Asis. So I can see there are just 16 participants. So we will just wait for a couple of minutes and then we will start. So in meantime, I let me introduce myself first. So my name is Ravi Shekhar and I'm having around 10 years of experience. Yeah, good evening. Okay. So most of the experience in this data science field, currently I am working as a senior data scientist. So my voice is clear, right? No voice issue, and even you can see my screen, right? Okay. So also you can see my screen, right? Yeah, great. So in today's class, we will talk about the natural language processing, NLP, right? And today we will see the basics of NLP, like what is NLP, what is tokenization, different aspects of NLP, along with one of the case study. In the next session, we will talk about the sentiment analysis, topic modeling, and in the last session, we will create a project on text classification. Fine. So these are the three class you have to be with me. Fiza, I think you to reconnect. Fine, guys. So this is the agenda for next three classes. So you have to be with me for those things. So I and also I hope you guys are already completed your the rest of the learnings. Like you guys are aware of the modeling process, right? Uh, Correct. So everyone is aware of the modeling process, right? So like in classification, what in any modeling, right? Classification, integration, what we do, we see the data, right? So we have some independent variable, dependent variable, right? And how we create a model, we will do some data pre-processing, then we will find some significant variables, and those variable we will use to predict our outcome. Correct. So what is the difference in this NLP? So Benly, the thing is here in NLP, Abhishek is also saying no voice. Guys, am I audible, right? Okay, so let me tell to Abhishek to re-log in. Okay, guys, so I think we are good to start the session. So I was talking about what is NLP, right? And in today's class, the first I will discuss about the case study. What is the case study? So everyone is much aware of the Twitter, right? So we have a platform, it's called Twitter, where people used to tell about, tweet about some of the topics, any topic, right? They will give their feedback, they will give their response, they will give their comments, right? But whatever they are doing, right, everything is in a text format, correct? So if you think like I have a word like this session is going on, so this is just a text. So if I want to create some model, I because my machine is not aware of the text, right, I have to convert it into a form where machine can learn the things, right? Either I have to convert into some number form, right? So how to do that, right? So that is we are here to learn about NLP. So the problem statement tells about the we have collected some of the tweets, right? And we have to specify which tweet is a valid tweet and which is not a valid tweet. right? Yes, no. So classification, it's just a kind of classification problem. So in the today's session, what we will see few of the things like stemming, lamenting, remove stop words, POS, word cloud, term frequency, IDF, LDA, right? So these are the things we are going to cover today. So let's start. So I was talking about what is NLP basically, right? So just now I said, right, as NLP means to interact with the human languages, right? It's a part of a AI that gives the ability to our machine to read, understand, and learn the human languages. Correct? Like whatever we are talking, the images, voice, videos. What are the mediums of things you can do? Okay, just a minute. Sorry. Basically, I was not showing actually, so I will put it here. Just a second, guys. No, no, what is happening? Is it fine now? See, if I am not able to see the chat, it's a bit difficult for me if someone is asking question or something because it won't pop up for me. But it's fine. I will maybe within few like 1 2 minutes I will check my chat window. So what I was talking about the NLP, let me maximize it, right? Okay. So I was telling about what is NLP. So it's a part of AI that gives the ability to machine to read, understand, and learn the human language. Fine. So most of the data we have right now, like due to this social media, most of the data in the unstructured form. Unstructured form means we are talking about the either it's in image, text, videos. So whatever Facebook, Twitter, any other platform, Instagram, WhatsApp, and all, right? Everywhere the text are there, which is unstructured data. So most of the data, whatever we have, are unstructured data, right? But that data contains a lot of information because if you just simply I'm giving example, I a movie is released last week, right? As a director producer, I want to see the sentiment of my movie, what is the reviews. So either I will go and check the critics, what are the critics there, right? I will see the review. Maybe I will do some analysis like how many reviews are positive, how many reviews are negative. Then I have a better idea about the how my movie is the if people are liking my movie or they are hating my movie or what kind of whatever I created, what is this, right? So to find some insights, right, to derive some information from those unstructured data comes under the natural language processing. Fine. Just a second. Oh, what is happening? Start minimizing. Okay. So I just want to see if someone have any question. I think now you guys are able to understand what is NLP, right? Right. So what is the what area is NLP? How we are going to discuss about NLP? Okay, guys, I will check in between. In meantime, I am just removing the chat. So, what are the applications of NLP? So, what is NLP? So, we have a lot of data from different mediums: mobile, web, computer, desktop, right? So many data unstructured. It will go to the NLP part, NLP layer, and then we will find some information from it, right? So how it will work, how we are going to change those words in a particular format so I can extract some information, right? Like in our another problem, single problems, what we will do, we will do data pre-processing part, right? Same we will do for our text part. So we will do some text pre-processing. I will go with once the class move, you know what are the things you need to do as a part of text pre-processing, right? And then we will have some other technique like tokenization, text to sentence, padding and all, right? In between we will do some EDA, right? We will see what are the features, important features, spelling and all. Then once the data is ready, what generally we do? We do modeling, right? We will use the models, and then we will find some information, we will predict something, or then if everything is done, we will deploy our model. Fine, right? Mostly this session will go as a practical one. So what will maybe after, since first 10-15 minutes I just want you guys to understand NLP. That's why I am just talking and going through PPT. After some time we will run the code and we will see how the things are going on. Fine, guys. So as we said, right, so now you have idea of NLP. So what are the areas, what are the applications which are using NLP? The very common thing is Google, right? When you use Google, if you try to type something like I want to learn NLP, I'm just putting NATU. The Google is telling me five options: natural language processing, NLP and all and all. How? Because there are some models which is running, which know what is the trending things in the web. So it know if someone is typing NATU, they are more keen about the natural language processing because this is the trending words. Most of the guys are searching, right? Sentiment analysis. I told you, right, about positive, negative, neutral reviews. You guys use Siri, Google Assistant, right? Where you just say something and system will respond. I want to hear some music. Okay, can you play this one? And YouTube will open and it will start playing this particular song. All this comes under the NLP part. Chatbots you have, right? Nowadays, most of the companies, what they are doing, even though an advisor, when you open the advisor portal, right, a, a bot will give you a message. Hi, I am your assistant. How can I help you? So it's a smart bot. If you type your query, it will search in his database and it will find whatever the relevant answer related to your query, and it will populate the answer for you, or whatever it feels it will, which is related to your doubt, it will pop up the things, messages, right? Text classification. The very good example for text classification is, you know, in our Google, most of the guys are using Google, right? So in our mailbox, right? So guys, I am audible, right? Again someone is saying no audio. I am audible, right? Hello. Okay, thanks. Okay guys, that's it. I just want to, okay, so just a second. So what I was telling, like in our Google email box, right, you can see we have some folder called spam, and most of the emails related to some advertisement, some junk mail, maybe spam mails are going directly to that spam folder. It is not coming in my inbox. How it is happening? How the Google knows like what mail is in spam category and what mail is in red category, not a spam, which is coming to my inbox. Those things also based on the NLP. So have a lot of application. Like in every field we are using nowadays NLP. It's vast, right? So we will go through this text mining, text process. Fine. So what we can do some categorization, classification. I will come back to, again to this. Like no need to come back to this slide, but we will go through this all things, whatever it is here. Okay. So, but again, there is some problem, right? So even words have different meanings in different situation. So guys, if you see this picture, right, and if you see the right picture, which is a chicken, so someone is saying the chicken is ready to eat, right? So what do you think? Either someone made chicken and they are calling their friends to eat it, right? Or someone is farming and it's time for chicken to eat, right? Getting my point, right? Doubt here? So there are two meanings for each word. Okay, good. Similarly, we have another example. If you see your left hand side, I saw her duck, right? So if I am a sports person, first thing in, and I love cricket, then first thing come in my mind is, oh, someone is throwing bouncer and someone duck, right? Maybe someone is farming duck and they went for a walk. So both the things is correct only, right? So we will say like if we have within a single word, within a single word, if we have two meanings, it comes under the lexical ambiguity. And if we have two, three words or a sentence which is having some two, three meanings, which is called as syntactical ambiguity, right? So this is the same thing I'm putting here. Now we will see a real example of an NLP problem. So there is a sentence, a dog is chasing a boy on the playground. Fine. So how this NLP works? So I will just do some part of his speeching, right? So part of his speech tagging. So I can tag each and every word, right? Like is a determinant, dog is a noun, chasing is a verb, boy is a noun, playground is a noun, right? We can do this level of exploratory data analysis on any text, where we can find what are the phrases used, what are the part of a speech for a particular word. We can convert that word into sentence, right? So now, as I said, we will go through the practical example. So very first thing, guys. So this is a very, just a second. Okay. So the most useful package is NLTK, right? So everyone has to first download this NLTK, right? So let's see how to download it. So other packages what we will use are pandas, which is common. OS I'm using to change my working directory, right? We will come back to this RE string, right? But the most important is NLTK. Okay. Okay, so let me run the things. First, let me clear all the output. So till now, what we discussed, just recap of things. We will see to the code. So what I said, so for our whatever the things we are going to talk in this session is about the tweet data, right? Twitter data. Fine. Okay. First import the data and let's see how the data looks like. So in meantime, anyone have any doubt or question? You can ask, guys. So I will just see the chat again. So Aditya, I don't know like why you want to be increase the pace. I know what I have to cover in today's session, right? So that's why I am going in that pace so everyone can understand. Maybe you have studied something so you are able to understand, but I have to think about everyone, right? So 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 don't worry. I will cover everything whatever in the today's syllabus. Fine. No, those are the two different packages, sir. So I think you guys will get all the material like PPT, code, and data set. I think it's already shared with you. I'm not sure, but generally what happened before the class, they used to share the everything, data set, PPT and all. But still, if you are not able to get the data set, drop a mail to support team. Okay, so it's still running. So, but I think you guys are aware of what is NLP, how we are going to do it, right? That is the first thing, the very first thing you have to understand. Now we will see the data, how the data look like. I don't know what happened today. Generally, I used to minimize this, but something happened. So major use of NLP, right? So the very, I told you that so many applications I told you, Sarath, right? So that's why I added that slide to tell you what are the applications where we use the NLP, right? So you just think like I told about the social media, right? Most of the things is for the social media. So what is your question, Kunal? Both are different thing, right? Both are two different area. In the real world, text analysis is different, data mining is different, right? So these are the two different areas. I'm not sure why you are getting confused here. Guys, Naveen is saying unable to see the screen. Are you guys also not able to see my screen? Okay, Naveen, can you please just re-log in? Okay, so what I was telling, let's see. The code has run now. Okay, sorry. Okay, so now I have just loaded the data. Now we will see that how data look like. So I have total 265 tweets and I have two columns, right? One first column is related to tweet and the another column is class. Fine. So you can see some tweet like if the press would cover me accurately and on duty, I would have far less reason to tweet or something. So this is our data look like. Before going into the data part, I will tell you what you need to guide. You have to do. You have to import the NLTK library first. Once you load the NLTK, you have to download all the dataset available in that NLTK downloader, right? So many things this NLTK has. So once you click on this NLTK.download, right, another pop-up window will display. So why is not going down? See, this will this will pop up, right? Since I already downloaded this, so you can see everything is in green. But maybe if you're doing first time, this will come in different color. See, it was earlier like this. So few of the identifier are out of date. So what I did, I just downloaded all. I refreshed and download all. Once you download it all, and I will close this. So these things you have to do. See, now it is coming as a true. The value is coming as true. So I have downloaded all the things available in the NLTK library downloader, right? If you want, you can see what are the things available in this NLTK with the help of this directory. It will show you the functions, attribute, and the dataset available in that NLTK package. So so many things are there, right? Like stop words, we are going to use some of them. Tokenizer is there, stop word is there, unigram there. Okay, so if you want, you guys can just go through it, like what are the things there in this NLTK with the help of this directory command. Okay, so now the very first funda we are talking about the tokenization. Now we know we have a word, right? I'm just skipping this installing part because I have already covered this. Right. So we will talk about the tokenization. So what is tokenization? So basically tokenization, during tokenization, what we will do, we have a full sentence here or a full paragraph, right? Maybe there is in a feedback, it's more than 3-4 sentences, right? There is a chance, correct? So what we are doing, either we convert all those words or all this sentence and paragraph in a word or sentence. So basically we have two kind of tokenizer. Either if I have paragraph of 4 sentence, I will do a sentence tokenizer. What it will do, it will check the what are the sentence there in my paragraph, and it will split it in 4 parts. Like if I have a paragraph like I joined the session today, session was going smoothly, right? If I run this tokenization, I will have a 2 sentences, right? I joined the session today, the first one, and the second one is the session was going smooth. Okay. Another one is the word tokenizer. In that case, it will convert each and every word. It will treat each and every word as a single token. Like it will just change it to I am, then join, then the. So whatever the words are there, right? It will create that as a token and it will split it. Okay. I think if you just see it, it is very easy to understand. So here I am using from NLTK, I am using this function tokenize, right? And I am importing 2 things. One is the first is the sentence tokenizer, sent tokenize, and another one is a word tokenizer, right? Let's see guys. So I have a document which is saying all word and no play makes Jack a dull boy, all work and no play, right? Okay, so first we are running the word tokenizer. You can simply say, right? So what happened here, After running this tokenizer, it converted my sentence into that words, right? Every word is a token. Okay, fine. Any doubt here in this word tokenizer? In case of a split, so what we did, right? We are doing the splitting only, right? What is happening in a split? Maybe it will not split it as a sentence. So this is a word tokenizer, right? Now we will see the sentence tokenizer. Now you can see this is one token, this is one token, and after comma another token, right? So it converted my paragraph into two sentences. Fine. Now I want to store these words and sentence into some arrays. So what I will do, I will just pass that phrase equal to sentence, word equal to one. So see, now you can see both the things are here. So this is first one is my sentence tokenizer, second one is my word tokenizer. Getting my point, guys, right? So how we will, first what we will do now you can see, now I have just a feedback or sentiment or anything, any review. Now I have converted that particular review in either words or a sentence. Why I am doing that? Because you see here in our case, we don't have any such kind of independent variables. So for us, what is the independent variables? How I know a mail is a spam or not? With the help of words only, because in that mail I have just words, right? Subject is there, inside that body is there, but everything contains a word, right? So with the help of words only we can decide either it's a spam mail or it's not a spam mail. With the help of words only we can see it's a good review, negative review, positive review, or neutral review. So all the words is our independent variables. You can treat words as an independent variable. Getting my point? Okay. Any doubt? Shall I move on? Okay. So now the second thing is anagram. So there is another question. Sir, you said we will convert into single word, right? That is fine. But what if I have two words which will give me more meaningful things, right? That is happen, right? So if I add one or two words, maybe that is more meaningful. But mostly the single word is more powerful, right? But maybe there is some chance in some of the data set or some of the data, if we just use two words as a combination, that is far better than the single word, right? Maybe three words, right? There is a chance we can do that also, that we call anagram, right? So it's unigram. What we saw is unigram. So I want the sentence in a two words, combination of two words. So I will use the same NLTK library and I will import the anagrams. Anagrams we can do. Okay, again there is a sentence and I am passing like what are the combination of sentence, what are the combination of words I want, right? I want a combination of two. Okay, so and I'm passing n equal to 2. So 2 means bi, right? I'm just adding that name as a bigram. And then I am splitting the sentence. Someone just asked, right? So what is the difference between split and tokenization? I think now doubt is cleared, right? Who asked this question? Okay, Himesh. So Himesh, this is fine now, right? Now you know what is split and then tokenization difference, right? Okay, just let's see how it look like. Now you see, so it is a combination of every time two words. How it is taking? First two word. This is one combination, one token, right? Another one is a second, a foo third, foo bar four, bar sentence five, sentence and six, and an I seven, I want eight, want to nine, two and grammar is 10, and grammar is 8, 11. So it converted my whole sentence into 11 tokens, right? Okay, guys, you can pass anything. Like if I'm passing n equal to 5, right? So I have first one, two. Okay, so I'm just giving one small question to you guys. If I'm adding n equal to 4, what are the combination? How many combination I will get? Just think about it. I am passing n equal to 4. So what is the how many combination I will get? 9. Aditya is saying 9. Okay, guys, try please. So just now I showed you, right, how it is dividing the tokens, right? Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. So whoever said 9 are correct. So if your thinking is more than 9, then again I'm telling you how it is converting. And 4 means 1, 2, 3, 4. 1, 1, 2, 3, 4. 2, 1, 2, 3, 4, 3. So it is going one by one, right? So this is a foo. Then it will start from is. Then it start from a foo. And last forward. When it come to want, this is the last combination, right? This will come as the last combination. So Anirudh, Sarath, just go through it, right? Any doubt? Anirudh, Sarath, it's not 13, it's 9. Fine? Getting that right? Okay. Along with this, even we can find something more, right? So maybe since I'm going to create a model, so I can add as much as features I can, right? So along with words, I can also think if my sentence is very big, right? Means if someone has to give some feedback and maybe there is a chance that feedback is very big, then this is a real feedback. If someone is just saying, I am loving it, I like this feature and all, so that will be, the length will be small, right? But if someone has some issue, right, then they will write a long feedback. Yeah, Himesh, I told you, right? So sometimes what happen when you create a model, maybe good boy, right? Good boy. If you just think about unigram, so good, separate good and boy have separate meanings. But if I'm talking about in this class, how many good boys, right? So good boy, if you take the combo, means it's they are a better than the other students, right? So it depends upon your data image, but mostly people use in unigram, right? Rarely like, because single word is always better powerful, because sometimes what happens if you combine two words, the meaning will get changed. Getting my point, right, Himesh? Okay. So I was talking about how to add some additional features, right? So as I said, if I am not happy, right, what I will do, I will write a big feedback. Oh, this feature is very bad. I didn't like this. I'm getting frustrated after using this feature and all, right? So maybe the length of those particular feedbacks are more rather than the, if someone is happy, this feature is very good, I like this feature. So that's kind of feedback. So we can add that length of the words also, right? Okay. So now you can see I used a frequency distribution from the NLTK. I don't know what happened today, guys. I'm trying to minimize it, even it is not allowing me to minimize. So see how the frequency distribution will come. This is for the word. I will just show you the what is the word. So, so this one, all, hear the word, right? This is the word actually. All work and no play makes Jack a dull boy. All work and no play, right? You can see all is coming two times, no coming two times, play coming two times, and coming two times, right? So it is just giving you what are the word frequency, right? So you know why we are doing this. I will tell you. So this is the next word is a stop word. So just see, most of the guys whoever typing here or something, whenever we type, right, there are some few common words which we use in every sentence, like I, and, on, ye, right, to, in, into. Puja, focus on the class. We will provide you everything. Okay, so first try to understand the things. Code you can find in, even don't bother about code, guys. You can get thousands of code on web, but the thing is you have to understand the concept first. Code, PPT and dataset is available. I don't know either you did already got it or not. Yes, Himesh, can you just provide the path where everything is there? So I don't want this question comes every time, where is the code, where is the PPT, because it is sometimes disturbing. Okay, so what I was talking about stop words. So we have some generic words which we generally use. So just think, if I, so everyone is using I, irrespective of neutral comment, positive, any sentiment, anything, everyone start with I am suffering from this. So that is very common word which will not giving me any information. Like in our modeling, like in our modeling, what we used to do, we will see what are the important variables which are impacting my dependent variable, right? And as I said, all words we will consider as independent variables. In that case, what I will say, no, yeah, this I, on, to, in are not the words which is really useful. So why to take those words in the further modeling? You can say this as a feature engineering, right? So I will remove those features which are not important. So okay, so I will, so we have some dictionary in a stop words, right? So I am using this stop words from the NLTK corpus. Fine. See, I just added, for example, I'm just showing what are the some stop words available in the dictionary. So it's I, herself, been, with, here, very, doesn't, own. I just printed some of the things here. If you want to see a list of directory, you can see the whole directory. Okay. Anyone have doubt about stop words? What are stop words? Why we are checking this stop words? Apart from Himesh, anyone have any doubt? Because I can see just Himesh is replying for everything time. So if you guys have doubt, just take. I'm going. Someone said I'm going in bit slow pace because I want you to understand, right? Okay, Vinith. Good, Vinith. So you have to ask if you are not understanding now. I am here to clear your doubts. Wait, guys. So stop word means, since when you do modeling, right? What we will see, what are the features which is not relating to my dependent variable. Mostly we will do in modeling, right? Like if some unique ID is there, why I need ID for my modeling? I just remove it. Similarly, in NLP, we have few words which we generally always every time use, most frequent words, right? Like I, herself, been, with, here, very, doesn't, own. It is not giving me any such importance. It's a full list of dictionary, Kunal. You can, that's why I just told you, I am just printing some 10 15 here, but it's a full which a lot of words are there. You can just go and check in stopwords.word. To just pass this English, remove this one. You can see all the words. Fine. Okay. So what I'm saying now, how to remove this? Now this is my sentence, right? This is a sample sentence showing of the stop word filtration. I am using word tokenizer because first I need to tokenize the word, then I can remove the stop word, right? Okay. What this code is particular doing? This is my sentence. I have set the stop words as English dictionary because our example is we are taking as an English one, right? Even we have some different language available. Okay. Then what I did, I just ran a tokenizer. Till now, I didn't remove the stop words, right? You can see whatever the sentence, I just tokenize it. Now I am removing the stop words. See, so it was a stop word. It is removed. A was a stop word. It is removed. So now see here, if you see, almost we have 10-15 words. Now after filtration, I have just 3, 4, 5, 6, 7, 8, 9 words, right? What I am doing, I am reducing the features. You can write the same code in a single line. Why I typed here, you can use a for loop, or better than this, you can use that in a single word, sorry, single line of code. Again, if you see, the result is same, right? We will combine each and everything, guys. Tokenization, stop word, punctuation. First, I am just in the first 1 hour. We will see one by one what is this. And then when we jump to our problem statement, we will do it together, everything. So we don't have to. So Kunal, if this is a stop word, it will remove, right? So I am not doing anything manually, right? Whatever it is written in stop word, if this was there, then it will remove. Otherwise, it won't remove. Getting my point, right, Kunal? Okay. Third things, what I am telling you guys, basically what I am trying to teach you here is how to do the feature selection, right? How to reduce the number of words. So we have, because if you think in general, we have just every time 10, 15, 18, or maximum 100, 200 variables. But if you have 1,000 tweets and you just remove the words, unique words, maybe it is 5,000 word or 7,000 word or 8,000 words, right? There is a chance. I have to reduce those features, right? Okay. Now tell me, yes, correct. We are reducing the dimension, right? The third thing is punctuation. I think everyone is aware of punctuation, right? Anyone who is having doubt about punctuation, what are the punctuation? Tell me. Anyone? Okay, if not, then tell me one. Give me some 2, 3 examples of punctuation. Okay, right. Fine, guys. Okay, let's see what are the things in punctuation. Okay, so these are the things comes under punctuation. Someone said no. So for Jitendra, you can see now, right? It's easy. Through code we can know. Okay, these are the things comes under the punctuation. Again, guys, what do you think? This exclamation, quote, hashtag, dollar, percentage, is it giving me any kind of information? I don't think so, right? Bracket, greater than, equal to, right? So maybe people used to do some kind of like I am happy, ha ha ha, and then something they will type, right? So you can say like these are the things we have to reduce, right? Because since if you see in tokenization, we are getting this as a token, like dot, comma, everything coming as a token, and this is unnecessarily, right? We have to remove all those things. I don't need these things, correct? Again, same. What I will do, I will just see here the text is hello exclamation plus how less than r greater than you double slash doing, right, pipe sign question mark. See, now after running this punctuation, I have removed everything. So my data is more cleaner, right? We are doing the data cleaning. Similarly, we can reduce the tags. So whatever the tags in the HTML body, we can remove with the help of another package called regex. Okay. Now removing numbers. If someone is saying 200 people, 80 people are standing, 20 people, 2 p.m., 10 p.m., right? Again, it is not giving me a particular idea because maybe someone typed 80, which is not related to any of the feedback or anything, right? So numbers in the case of text analytics is not feasible to take. Only numbers like frequency, length, that we can take. When we do frequency and all, we are adding that as a feature. But here this feature is not useful because maybe one out of 200 sentence, in 10 sentence there are some numbers 80, 40, 60, 50, which is not having any meaning. No, Jitendra, this smiley will not handle, I think, right? But you can try. I never tried because when I am running, I'm giving this smiley sign. It is not coming. It is coming as a punctuation only for me. So I didn't try it, but maybe you can try. So again, so I don't want such kind of numbers in my text. Remove it. Removed. Okay, guys. So now again come back to PPT. So we have covered this one. We have covered the tokenization, right? So here is the same example. How we you do what tokenizer, what is n-gram, bigram. So again, same, just a recap kind of thing. We can just go through it quickly. So it's a recap for guys who are maybe not understanding the things. Because I assume someone having the code and all, they have gone through it and so they have some knowledge, and someone who is not having the idea about the code is available or something, maybe they are first time they are just looking it, so let them go through it. So N1 means, guys, unigram. I've converted this sentence into 4 tokens. N2 means bigram. So 1, 2, 3, right? So this is the length of this sentence is 4, right? But if I'm using n equal to 2, it will convert into 3 because the last, it will combine this last two, right? So this is a sentence. If I'm using n equal to 3, it will convert it to just 2 part. This is a sentence. Fine. Okay, so we already gone through it. Stop word means there are few stop words already defined in English word. We are going to remove all those stop words from our sentence, from our paragraph, from our tokens, right? Because those words are not important for me for my further analysis. Okay. You can see example, geeks for geeks, a computer science portal for geeks. This is a word with stop words. If I remove the stop words, it will remove for, right? Maybe the dash will come. I think I did some punctuation on the dash, but it will just remove a and for. Okay. I know I'm going a bit slow, but it is good for you guys only. And don't worry, I have everything in my mind what I need to cover. I will cover that. So you can see we have around 51 slides and we covered almost 50%. Again, so see Sankal, there are few things, right? So either if you don't, if for Hindi words you can't use this in English stop word dictionary, right? Then I told you about word frequency, right? And few things. First, you need to check the words. How many words are like that, right? Either you just remove those words or you can just reiterate. So you can just change that, convert that word into English, maybe with help of coding, right? But if you use this stop word as English, it will not handle those kind of Hindi language word. Okay. Punctuation again. These are the punctuations. This is the example of punctuation. I don't want this in my data set. I am revoking it. Fine. Now come to the regular expression. I think this is a very generic topic, guys. I am not going much through it because I have added so much of regular expression in my code. So if you want, you can go one by one, but a few important things we will discuss. So Himesh, I told Sankalp, right? So I I don't know. Maybe there is maybe new. They have added some new package or not. But recent times I didn't see any package which is handling this bilingual text. Either you have to find out such kind of words and treat those words separately, right? Or maybe like nowadays it's most common in India only, right? Where we are using this Hindi English mixture of everything, right? Most of the rest of the world, either people use their own language, like Chinese, they use their Chinese language, Japanese language, Russian. Only we use a mixture of text, Hindi, English, everything, right? So most of the packages, whatever is available, it talk about different language, either in Hindi, Russian, English, Japanese, and all and all. Okay. So I think this regular expression is a common thing which most of the IT background guys aware of, right? Where we used to check a kind of expression is there in my data set or not, right? If I have to find something is matching, I want everything is starting with S. I want a word start with at the rate, right? I want the words which are having exclamation mark, right? All those searching pattern, checking pattern, matching and all, we can easily do it through this regex. Okay. So I will just quickly go through few. I am not going to run all the code here because this is a very common generic thing. But for giving an idea, which is who the guys who students who are not aware of regex, right? Regular expression, right? So for them, I just added this. So we have a package called RE, right? In the beginning, I told you there are few 2-3 packages which I tell you once the that we will talk about that, right? So this RE package we will use to check the regular expression. Fine. So I have a text you can see. So I want to find, right, all the strings. So this one, find all text. What it will give? It will give me the start of the string, which is E. Now I want all the character, correct? So I will use this plus sign. So I have already mentioned these things here in the code, guys. So if you have any doubt, just go through this above one. How it is doing? So it is finding and printing. What else will give? It is you to create a space in the string, right? So it is just dividing this in, after it is checking a space and it is putting that as separate one. Few messy things we will see. Hmm. Okay. So I am checking here. I am splitting the words with the help of white spaces available in the sentence. Right. Okay. I think you guys can go through it. Right. So you have already the code. Few things like start and end with. Okay. So I am just finding the word in with number. Start with a number. Basically, this is to find the to check the pattern matching. Okay. I'm just skipping this because this is not directly related to NLP. But sometimes what happen if you have to find some kind of pattern in my data and all, we can use this regex. Is it fine, guys, or you want me to run through the code quickly? Himesh, just wait. Let the others reply. Okay, because this is just a common thing, guys. It's not much related to our NLP something, right? Just pattern matching kind of thing. Like here, if you see, I want like in a one of my sentence, I just want to find what are the email address, right? So I can just simply find wherever it is at the rate, it will consider those as an email, and I will get that result. I can easily filter the all the emails, right? What I am planning, I will just cover this stemming and then we will go for a short 5-minute break. You guys need a break or not? First tell me. If not, then we will go ahead. We will continue the class. If you guys feel like you need some 2-3 minutes or 5 minutes max break, we can go. Just let me know. So see, either we will go for break now or after this stemming and lamentation, because these are the another new topic which is really important. Okay, let me finish this, then we will see. So what is stemming, guys? Okay, and once I will go for break, I will have a quiz for you guys. So once everyone will back, I need the answer for this quiz. I will just put in on my screen and then we'll go for a break. Okay, so stemming is, so in our general things we do normalization, like standardization, normalization. What way we'll do? We will giving the weightage of every column, we are giving the same weightage, right? Same in our text analytics. Just think, if we have 5 words here: politician, politicians, policy, politics. Basically, if you see, all these words are talking about policy. Maybe politician is something different, right? Just see this example: consign, consign, consigning, consignment, right? The base word here is consign, but if you are putting all these 4 words together, it will consider this 4 word as a separate word, separate 4 words. It will not think like, the machine will think like these are 4 separate words, right? Because someone has suffix, someone is verb is changed, something is changed, right? We have added some suffix, prefix or not. So how to handle this kind of words where all the 4 words have same meaning, right? All the 4 words have same meaning, but since we are using some different form of form or adding some suffix, prefix, it is considering as a separate words. So here we will use stemming. What stemming will do? Don't do so much trouble for me today. So see what stemming will do. It will convert all these 4 words in a single word. Like it will change this consign to consign, consign to consign, consigning to consign, consignment to consignment, consignment to consign. So now your model will treat all 4 words as a one single word, which is consign, right? Getting idea what actually stemming is? So wait, Himesh. let Himesh will reply at the end, okay? I'm just kidding, Himesh. You can reply. Okay. Another thing is limitation. This is also doing the same thing. The only the difference between stemming and limitation is if you use limitation, it will convert into the dictionary base form. Getting right? But in case earlier case stemmer, it used to just remove those suffix and it will give you a different word. Both having said their own pros and cons, right? Sometimes stemming will work better, sometimes limitation will work better. But people generally say like since limitation is converting into the dictionary based form, the limitation is better than stemming. But it's vice versa. Like sometimes depends upon your word dictionary and all, whatever the words you have, right? So these are the concept of stemming and limitation. Now what we will do, just we will run the code and see. So once you see it is, you have a better idea actually, rather than going through PPT. So even again, for stemming, we have few other options. Like I am using here Porter stemmer. We have few other stemmers as well. Snowball stemmer is there. So you can use anyone. You can even you can run and see how this different stemmer has written, right? They have some stemmer have dictionary, different type of dictionary, but more or less everyone will work like same. So I am just running a word having, right? So what will be the answer, guys? Tell me. If I run a stemmer, what I will get? Okay, have, having, have. Last 2 seconds. I'm going to run this now. Okay, so it's have. So Anirudh, I just told, right? So what it will do? It will convert into the base form, right? Again, Python, Pythoner, Pythoning, Python, Pythonly, right? So what do you think, guys? Maybe some different answer you can see. Okay, okay, let's see. Oh, everything is Python except this last one. Because this is thinking like this ly is, he has changed this ly to li. Almost 90% times we are correct. What was for one word we are getting bit different, because maybe it is treating this word differently, not like this all these 3 4 words. Okay, okay, now we will see on some bigger sentence, right? So this is a sentence. I am running my stemming. Let's see how the result will come. See, it converted this to thi, right? So again, it is thinking this is not a base word. It is thinking this s as a prefix, right? And it is removing demos. It removed s. Texting, it converted correctly, text, right? Using, use, correct, good. So we have some issue also, like it is converting this to thi, but most of the word it converted correctly, right? So there are few, I told you, right? There are some issues with the systemic. Sometimes it is nature, it is converting to natur, language it removed e. So these things. Okay, let's see the another stemmer then. Snowball stemmer, how this works. Same, we use the same sentence. Now I was telling you, right, you can use 2 3 stemmers and see the result for the same sentence. Okay, now this is converting correctly this. So I can say for this particular sentence, my snowball stemmer is giving better result than the water stemmer. Fine guys. Okay. Another one is Lancaster stemming. Okay, just run quickly and see how the results look like. Again, this is converting this to thi for helpful, full. So in this case, this snowball stemmer is better than the other two stemmers, right? Shall I move on, guys? See how many stemmers we have. Portal, Lancaster, let's be stemmer, regex, snowball, stemmer, I, word net, lematizer. So you can check the directory and you can have all the things. Okay, after this limitation, we will go for a short break of 5 minutes and we have to back by sharply by in within 5 minutes. Okay, same. Now I am running this. You can see following mice attacks, caring farmer were matching to Delhi for better living conditions. Following it is didn't converted as okay. Sorry, this is the tokenization. This is the limitation. So again, we are using the same NLTK and using here word net lematizer. Like stemmer, we have some options here as well. Now you can just see the words and see what are the things it converted. Tell me one word it converted. What I said, it will convert into the base dictionary form. Correct. So mice was a plural, it converted into mouse. Right? So I think you guys have, after looking into these two things, you guys have better idea what is stemming and what is limitation. Right? You can also pass what we want. I want verb of this word. I want noun of this verb. Sorry, word. So V means verb, and for noun, I'm just passing. So it will give me verb stripe, right? There are few options. We will discuss this about pause maybe in the next class, because this we have to go in more detail. But I am just giving you a glimpse. Here, what I am doing, I am just checking what are the part of speech for each and every word. Like following is a verb, mice is a noun, attack is a noun, caring is a verb, right? So it is giving me all the speeches, right? Yes, Aditya. In case of limitation, it will convert into the dictionary form, right? Which is mouse, not mice. You can use wordnet also. See, I'm using this wordnet limitation. So this is the same sentence we used for the stemming. So you guys can run maybe with the same sentence, you guys can run some stemming and limitation, what are the different options, and see how the results varying, right? This is one task from my end. Okay, guys. Okay, so it's 5:15. I'm giving a short break of 5 minutes. We will back by 5:20. I will start exactly at 5:20. I will not wait for anyone. Fine, guys. So 5 minute break is enough. So I don't want to lose the concentration whatever you guys are studying, right? But I also want you guys to get some refresh, right? Go and get some tea, coffee, whatever you like, and then back by 5:20. Once I back, I want the answer for this question. So I am maximizing it. I will check everyone's answer once I will be back. Okay, we'll back by 5:20. Hello, I'm audible. Okay, so most of the answers CCC 8888888899 also is there. Okay, so I think We'll go for the maximum voting, right? Mode option. So I think it's 8. So 8 is the correct answer. Fine. Anyone have any doubt why 8? 1, 2, 3, 4, 5, 6, 7, 8. 8 option. Okay. So then we will move on. So regex we already saw. I hope everyone is back, right? Okay, this is the another question, guys. Again, quickly go through it. Which of the following techniques can be used for the purpose of keyword normalization? The process of converting a keyword into its base form. I don't think anyone have any doubt here. So the answer is 4. Correct. Or we just now we discussed. So means maybe you guys are more active today. Okay. The next is bag of words, right? So what I will do, I will just quickly go through this PPT and then we will see in the, we will just go through the practical again, right? So it's a combination of both the things. So what is bag of word? So if you see, I have two documents. The quick brown fox jumped over the lazy dog back. Now it is the time for all good men to come to the aid of their party. So what bag of word will do? It will mix all the unique words from document 1 and 2, right? If you see, we have around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 words. On how it is creating this bag of words? Now it will put all the words in that row and we will see in document 1 what are the words available. So aid is not in the document 1. That's why here you can see 0. But in document 2 we have aid, right? Similarly, all is not in document 1, but it is available in document 2. So basically this is giving you the frequency of that word is available or not, right? So it creates a matrix actually. So whatever are the sentence or documents we have, and then it will give the frequencies of that particular occurrence of the word. Okay, any doubt? So good. So we will move on. Now this is bit short how we are putting that bag of words. The dog is on the table, right? And the words are R, cat, dog is now on the table. So R is not here, so 0, cat not here, 0, dog is here, 1 is here, 1, now 0, 1, 1, 1. All things are there. So here the word is 1, 2, 3, 4, 5, 6, but here is 5 because they came 2 times. It is, we did one hot encoding where we used to do labels into 0 and 1. Okay, so Kunal, if you see, there are some common words also here. Maybe not common. Then in that case, if just assume all is common in both the document. So it will say 1 and 1, right? Both are having 1. We have this document 1, this is document 2. So like one hot encoding, we have bag of words here. Okay, now this is important. Term frequency and inverse document frequency. Be careful, this is very important thing. Now what is happening? So in the initial days, what we used to do, we used to take the frequency of words and then with the help of bag of word, we used to create a model. The only issue was we don't know which word we have to put more focus. Like, because every word has same weightage, right? We are just giving frequency 2, 3, 4, 5, 6, right? And I said some common words which are more frequent, maybe that is not much useful. So this, so we are using TF-IDF to give the weightage to each and every word, which signifies the importance of that particular word in the document, right? So term frequency, what is term frequency? So it is actually two things, term frequency, and the second one is inverse document frequency. So first I will talk about the term frequency. So term frequency basically is the, if you have a particular word, right? So what is the frequency of the word in that sentence? And what is the total number of words in that sentence? Once we see the example, that is much easier. So if I'm just saying this example, the dog is on the table. So I have 1, 2, 3, 4, 5, 6 words in a sentence. And term frequency for dog is 1 divided by 6. Term frequency for is is 1 divided by 6. Term frequency for the is 2 divided by 6. Because it is coming 2 times. Getting my point, right? So how many times it is coming in that particular sentence, divide by the total length of the sentence, total words present in the sentence. Anyone have any doubt apart from Himesh? Okay, great. This is the first class in which students don't have any doubt. That is good actually. Either two things, right? Either you guys, I am teaching so good, like you guys are maybe able to understand the things. Or second thing, maybe you guys are not having much interest, so you are not asking questions. But I will always hope for the best. Okay, now the second thing is inverse document frequency. What it will say is, it's okay, thanks Kunal. So what it is saying, now what I said, we have to find the rare words, right? Rare word means the occurrence is less within whole the document, right? And we are taking the log of, so IDF is total number of sentence, how many documents, right? Divide by the, this is the formula guys, actually you have to understand this formula. Like once you read the formula, I will show you through the example, that then once you have the formula and then see the example, then it is easy to understand. So I am taking IDF means log of n divided by NDFT. What is n? N is the how many sentences having that particular word. No, sorry. N is the total number of documents, right? If I have 10 feedbacks, right? So I have 10 documents, right? 10 different feedbacks. And in a word like issue, issue word is in the two of the sentences, right? So there are total 2 documents containing that word, right? So it's 10 divided by 2. Okay. Now just concentrate on this particular slide. Okay. So I have 2 documents. One document is saying the car is driven on the road. Another document is saying the truck is driven on the highway. Let's find the common words first. So the car is driven on the road. I have kept on the same, right? Now the already present, truck, already there, here, is there, driven there, on there, the highway. Okay, right? So what are the total number of unique words? Tell me. It's very easy. 9. Right. Now I will find the term frequency in for document 1. So for document 1, the term frequency is 1, 2, 3, 4, 5, 6, 7. 1 divided by 7. So here I have put the 2 times, right? Maybe it's not unique I put. So that's why I kept this. For understanding, I am just made it simpler. I just put everything here. That's it. So this is the first word, 1 by 7. This is the second word, 1 by 7. This is the second word, car, 1 by 7. Right? This is not available in document 2, 0. Truck is not available in. Is the second the supposed to be the. Yes, Sumedha. So actually what I said now, I just for understanding this TF idea of how to calculate, I just put everything here. So don't get confused. If I am talking about this D, right? Because why I put it here? Because this is, if you see the case is sense, it is the case here is caps, but this the is smaller one. So I am considering these two as a two different separate words. Getting my point, Sumida? So this the is different from this the because this is caps, this is all small. Okay, the formula is this one. Abhishek, just read once. So you have idea. Document means number of, just I showed you document, right? Sentences, right? Okay. And more or less you guys have everything, right? You guys will get code, PPT. So formula, everything is there in PPT. I have created such like not able. I just want you to just be with me. You will get all those formula. Then what is IDF? See, term frequency is very straightforward, right? This divided by total number of words. This divided by total number of words. Okay, right? IDF is a bit tricky. So there are total 2 documents, right? Document 1, document 2. So log divide by total number of document, which is 2. So in every case, it's 2 only. You can see, right? Divide by. This D is coming in both the documents, right? So 2 divided by 2. This card is just in one document, right? So 2 divided by 1. Truck is only in one document. So 2 divided by 1. So this is the total number of documents divided by number of documents containing that particular word. Doubt? Anyone? Now, what is TF-IDF? I will just multiply these two, right? So TF-IDF is just multiplication of this TF and IDF. You can see this is the TF-IDF. Okay, if everyone is saying no, tell me the answer of this. I'm giving 1 minute of time so you guys can read properly, and then once read go through it, then tell me the answer. No answer still now. Okay. I don't know, guys. This is not minimizing today, so maybe I am getting bit irritating due to this, but it's fine if you guys are able to see it. I showed for 2 3 minutes. So you go with the definition. What I said, log of number of documents divided by how many documents contain that particular word, right? So what is n, what is k, Abhishek? It's everything is given there, right? Because I can't see answer log n. Something is there is 3, or you have to just say 1 2 3 4. Okay, two answer with B. I'm considering Abhishek and so also B. Himesh, there is no option called 2. Okay, Goku is saying Gokul Krishnan, right? Is saying it's D. Okay, so most of the guys are saying B only, and I think this is the correct answer. So term frequency means K divided by T, log 3 divided by 1. So it's K by T into log 3. Fine. You guys are great actually. Learning so fast. Okay, so now what we discussed, we will see for the next 30 minutes. We will look into that, and then last 10 minutes we will go for a question answer session if anyone have any doubt. Okay, so this is the count vectorizer, right? Okay, so guys, just now I showed you, right, that one bag of word kind of thing, right? So this is the same. So again, I have been using the same word, same document. The car is driven on the road, the truck is driven on the highway. Okay, so I am just running the transform on corpus. What I am getting here is 1 2 3 4 5 6 7 8. Now someone Sumedha, right? So you asked why there are two the, right? But here it is single, right? You can see there is only one, because we didn't consider that. For just putting as a straightforward simple example, I have added both the things because one was in caps and one was in small letter. But when we run on code, it is considering this as a one. Fine. Can anyone tell me what is this 6 and all? What is this 6? What is this 0? What is 3, 1, 4, 5, 7? Yes, correct. Index. So it's just alphabetically. So in Python, we index start from 0. So car is first, then C, D, then H, right? So I think you guys are brilliant. Okay, now I am checking the shape. So 1 1 0. So if it is present, this is 1, otherwise it's 0, right? So this is the bag of what we saw in the PPT. Now move on to TF-IDF. We will use the sklearn library for this TF-IDF vectorizer. So basically what we are doing, guys, if you just now thinking, we are converting everything into a numbers, right? So we saw 0 1 0 1. We are not everything, whatever the words is now is a variable, and then we have either if it is present then it's 1, otherwise 0. So now the values are as in a numbers form which machine can easily learn, right? That's why we are saying vectorizer. We are vectorizing the words. See, now I am running the TF-IDF. Okay. So, okay, this is the same we saw already. Now we can see here, last one. So I have to convert into data frame. In the earlier case, we are getting 0 1, which was not that much important because everything is 0 1. We don't know which word is more important. But here you can see the word is having some numbers associated with it. Just a second, guys. Yes, we are giving weightage to that particular every word, right? So the model will easily know. So if some word is very rare, right? Which word is rare, which word is common, it can easily understand. Since this is just 2 documents, so maybe it is not giving get you that much good idea. But if you have more document, it will give you better idea. Okay. Now, guys, we will just quickly go through all the concept on our real data set. What are the problem statements, which is the Twitter data set. So I am just loading the data again. So this is the data, right? So what are the things? Just type me here in the chat room. What are the data pre-processing part we used to do? What are the things we are going to do? How to clean the data? Kunal, what you are asking? What is 0 and that is the seat number. So it's taking the first seat tab, right? Even if you remove it, it will read. Okay. Great. So I think more or less everyone has added one or two things. If we combine everything, it is a full process of data cleaning, which is remove stop words, tokenize it, check missing value, right? Stemming or limitation, remove punctuation, remove numbers, remove tag, remove. Okay, let's see. So first what we are doing, we are removing the tags, sorry, punctuations. Okay, so now you can see how it look like. So it will give you more clarity. This is my real text. This is my clean text, which is don't having the punctuation. If you see and here, there is no and here. At the rate here, there is no at the rate here. I didn't did the tokenize. I just converted. I just removed the punctuation from my text. Okay. then split the data, means tokenize the data, right? Great. Now I have tokenized the data. I use the clean text and I tokenize my data. From here, and there is no and here. Now I am going to tokenize this clean data. Okay, but what about the stop words? Okay, then run the stop words. Now, first is original data. This is after punctuation. This is tokenized, and then after that we are removing the stop words. See how we are reducing the dimension of the data, right? Everyone is fine. Since I am not, you can remove the, you can use the tagging on all tag the numbers, right? So mostly what we will do, we remove the punctuations, we do remove the stop words, and with the tokenization. These three things generally we used to do. I didn't added everything like remove tag, remove numbers and all. Okay, but you can do. Okay, guys, fine. Great. Now again, there is a pain, right? What I did, I write a long, so many codes. Correct. So is there any way to do all the things in a single code? No, Abhishek, I didn't did that, but you can do that. Okay. So guys, you can, if you want to check the missing value, right? So any text is missing, you can do that. Okay. Okay. So now I was telling like do the things in a single function or something. Fine. So this is, I have written another code. What it is doing? It is removing the punctuation. So it is joining the words from the text where word is not in string of punctuation. Good. After that, I am taking the text and I am doing the tokenization. Good. Then again, I am using that token and removing the stop words. Right. So a single function which I named as a clean text. Okay. And I am using that function to do all the processes what we did above. See, you can see now in within a single function I did everything. This is my original text. Here no stop words, like sorry, I use stop words, remove punctuation and tokenize the data, right? And how I did it, I just showed you, right? First I remove the punctuation and then I use that same text to tokenize, and then I use the same token to remove the stop words. Now I have cleaned my data and my data is ready. You can even check the missing value. You can just remove the tags, numbers and all and all. Okay. The last part is I am using lamentation. You can also use stimming, right? So I took the tokenized text and I just applied the limitation on my text. So it will limitize the data. So from this to this, right? If we just quickly check some words which we limitized. So if you see first, you are finding any word, guys? Quickly, just see what are the difference between any word between these two. See, here's something called 50, right? I didn't remove the numbers, but you guys can remove the numbers as well, right? Correct. Companies to company. Here, last one itself, right? So now we see how it is working, how it is implemented in the game. The last thing is, guys, word cloud. Okay, so we can even visualize the words. So we have to use the word cloud package, right? From word cloud, you have to import word cloud and image color generator. So how this word cloud work? I'm using the same our tweet data. So word cloud is basically like, it's a cloud of words, right? In word cloud, you can even pass your own, even you can anywhere you can pass your own stop words. If you think some words are coming frequently, how to check that? Either you check the word frequency, and most frequency of the word something is coming which is not actually useful, you can add that as your own stop words and you can remove that. See, this is the word cloud. Fine. So what I have some text, I am finding the words in that text. So if you see something is bigger, something is smaller. Bigger means most frequent, most most time it is coming. Smaller means it is like, if someone is having frequency of 100, that will come bigger. If someone has frequency of 10, it will come smaller respective to the bigger one. See, this is the cloud we got. So we can see HTTPS, CO. So most of the tweets having this HTTPS word. After this, thank is there. Then you. So I think you is not useful. Maybe it will remove by the stop words. Then you can also find some words which are not useful and you can remove it. Okay. And see, after doing everything, how I converted my features. So now I used here what I used, I can again show you. So I again downloaded the data, right? I cleaned my text, right? Just now we saw punctuation, tokens, right? And then I'm using my TF-IDF vector on whole of the data set. And then finally my data set look like this, where this 100, 10 AM, 116, 117, 2016, these all are the words available in my tweets, right? You can remove this word, these numbers and all. Since we didn't remove the numbers, you can see these numbers are coming as a column, right? So around 1288 columns words we have out of that 256 tweets. It's just displayed at $10. So since everything is zero, why it is showing zero here? Maybe all these are not available in the first sentence, first document. We are not able to display everything because we have 1288 columns. We are just displaying few 10, 15 columns. And those columns are not present in my first 10 documents. So Kunal, that is not the thing to how much columns we can consider, right? You can't, don't do things unnecessarily. Like if something I don't know, I simply blindly I don't remove the words, right? What I will do maximum, I will do some stop words. I can remove the numbers which I didn't did, right? You can remove the tags, right? Even I can see the word cloud, right? And I can, from the word cloud, I can find what are the words which are coming just one or two times, right? And which are not useful. And that is not useful. I can remove those words using my own stop word. In case of text analytics, like 110 column is very less because it's, you can say just 110 words, right? But you can display, but I don't think you can display 110 columns, but you can display some 10 to 15 columns at a time. And we have some options called pd dot options. If you want, you can change the options from default to someone, like if you want to display 20 rows or 30 columns, something, you can change that using the PD options. So Jitendra, I told you, right? So either two things, mostly we have to convert every words into machine learning form, right? Where it is numbers. So there is two way. Bag of words. Bag of words is just giving you a frequency. Either that number is present or not, right? And present to how many times it present. But TF-IDF is telling you that particular word, right? If I'm talking about a particular word, how frequent that is in the full documents. Is it a very common word which is coming frequently after every something, right? Or maybe it's a very rare word which is giving me more information, right? So when you use TF-IDF, for every single word you have some weightage. But in case of bag of words, you don't have such kind of information where you can simply say like this word is more important than the other words. No, Kunal, you don't have to change the column name, right? What is this question, Jitendra? Does kind of similar work as word cloud means? I'm not getting this question. Can you elaborate your question? I'm not able to get it. What does mean kind of similar work as word cloud? So guys, last 10 minutes, you guys have any doubt, anything you can ask now. No, Jitendra. See, word cloud is different, right? Through word cloud, we are just finding that particular word is coming how many times, right? So that is the frequency, correct? And what TF-IDF is doing, just let me show you. See, actually, we are vectorizing. Finally, we need to vectorize either two way. Either we have to use bag of words, count vectorizer, and just put 0, 1 here in every row and column, which is frequency. Or we have to use TF-IDF to give some weightage to all the words, right? So in that case, something will come as 0.32, 0.38, 0.46, and all and all. So Kunal, why you are not trying by yourself, right? I can show everything. Even it's already there in my code above. I know, but I want you guys to try something from your end, right? So if everything I will do, what you will do for the next class? So you have 1 week of time to go through all these codes, do something extra, whatever I taught you, right? Like I just ran these three things. I didn't remove the numbers and all. You can see numbers are coming right here on the columns. Okay, Kunal? But if you are not able to do it, next class, we will go through it. That is fine, Kunal, right? Right. Then only you guys will learn, guys. So do something extra from your end, because it's already done. You can just simply run the code, you will get answer every time. 10 times you will run the code, 10 times you will get the result, but it won't help, right? Okay, Hitesh, you have any question? So long you didn't type anything, so that's why I'm thinking. Apart from Kunal, Jitendra, anyone have any doubt, or are we good to? Just kidding, Himesh. Yeah, just try something else, right? So whatever I taught you, right, you just do something extra, remove tag, remove numbers, and see, try to learn this TF-IDF and that word, bag of words, right? Take the same data set, do the both the things. Yes, Kunal, I think I am also leaving, so I think happy weekend. Almost weekend is over, but still there are few hours you guys can enjoy. Ritesh, that's why I told that is word, bag of word is giving you frequency. So for getting the importance of word, you can have to use the TF-IDF instead of word of bag of word. You can use TF-IDF. Okay, guys. Happy weekend to everyone. We will meet in the next class.